So, my name is Hannah, and I'm studying chemical engineering and bioengineering, and I'm a summer student in the Shootdown Lab this summer. So, for the experiment today, what you will need is a balloon, or if you don't have a balloon, you could also use just a milk bag and a bag clip you could use to seal it up, a marker, a measuring tape, or if you don't have that, you could use a string and a ruler. And also you will need your freezer. So what I'm going to talk about today is the ideal gas law. And I'll explain that in a bit, but first, what I want you guys to do is take your balloon and you're going to use your measuring tape to go around the middle of it. Doesn't matter, it doesn't need to be exactly the middle, but just use your measuring tape to go around like that, kind of like that. And then with a marker, draw on your balloon where you put the measuring tape. Doesn't need to be exact. Just draw around there, just to mark where you had your measuring tape. So, after you've done that, you're going to want to look and see. So this one is 60 centimeters around this balloon right now. So in fact, I can even write that on the balloon. So, now that you've done that, or if you just have a bag and a bag clip, you would just seal up your bag. And now, you can put this balloon in the freezer. Sorry about that. So, I've already put a balloon in the freezer before I started this, but you guys can do that now and just wait, and I'll show you what happens. So, when I take this balloon, I'm not going to take it completely out of the freezer, but I'm going to just quickly, before it warms up too much, quickly measure around this balloon. Now I'm measuring 58 centimeters around this balloon. So when I put this balloon into the freezer, it was about 59.5 centimeters. So now, and now you can see actually that as it's out of the freezer and is warming up, it's going back to that diameter. It's increasing in diameter. So, in circumference, sorry. So why does that happen? Why, when I put the balloon in the freezer, does it get smaller, and when I take it out, it gets larger again? What's happening? So the reason behind this is, I'm going to tell you what the ideal gas law. So the ideal gas law is this equation right here. PV equals nRT. So what does that mean? So the terms in this equation are pressure, volume on this side, and moles, or just amount of gas, R, which is just a constant term, and T, which is temperature. So what this equation means is it relates all these variables together for a gas. And people already know the states of matter: solid, liquid, and gas. A gas is what is in those balloons, like air and oxygen and nitrogen and all that. So this is an equation that describes how a gas behaves, and an ideal gas behaves. So what's happening when I'm putting this balloon in the freezer? Well, temperature of the balloon is decreasing, right? So let's draw that. We'll draw temperature is going down. Now what's happening to N and R, moles, and that constant? Well, nothing's happening to the constant because it doesn't change. Nothing's happening to the moles of gas because I'm not letting any air in or out of the balloon. So none of those change. So these are not changing. So that means that this side of the equation, these terms, pressure and volume, must also decrease when temperature is decreasing. In this case, we saw that the volume of the balloon was decreasing after it got colder. So that's what was happening there. And if you were to have, like I put in the freezer already, a milk bag, for example, in case you didn't have a balloon, you can see the same thing. So, you can see that right now, it'll probably be difficult to see, but this milk bag has dents in it. It doesn't look very full of air. The volume looks pretty low. But now as it warms up, it's filling up again. The volume is increasing again. Yeah, see, now it's pretty. So that's the same thing.